Hi and welcome to JAD Math Academy. In today's video, and as an introduction to limits, we are going to know the meaning of the limits. So we write it as like this, and we read it as the limit when x approaches a or tends to a of f of x. So basically, when we talk about the limit, we are not interested to know what's happening when x is equal to a. And this is the difference between the limit when x tends to a of f of x and f of a, which are completely two different things. So when we are looking to know or to find the limit, we are interested to know the behavior of the function when x approaches a, when x tends to a, which means that when x is very close to a. So this is a. We are not interested to know what's happening when x is equal to a, but we are interested to know what's happening when x gets very close to a from the right side, and we call that the right-sided limit, a plus, and from the left side, and we call that the left-sided limit. So we want to know what's happening when x gets very close to a from the right side and from the left side. And we must have the both left and right-sided limits must be equal. So if we find that the right-sided limit and the left-sided limit are not equal and have two different values, so in that case we say that the limit does not exist. So we must have the both limits existing and are both equal, and in that case the value of the both limits will be equal to the limit when x tends to a. So basically the limit when x tends to a of f of x must be equal to the limit when x tends to a from the right side and from the left side. And so as we are not interested to know what exactly is happening when x is equal to a, so the limit and the image are two different things. So maybe sometimes they might have the same values, sometimes they might have different values, sometimes we might have or we may have the image but not the limit, or the opposite, we might have the limit but not the image. So to better understand the notion of the limits, let's consider a function as an example to better understand. So let's consider the function f of x is equal to x squared for any value except 0. So for x for any value except 0. So 0 is not included. and equal to 1 for x equal to 0. When x is equal to 0, the image is 1. Okay, so let's consider this function as an example. So the graph of this function will be something like this. 1, 1. Okay, so this is the graph of the function x squared, but we have the 0 is not included here, so here we will have a hole. Okay, and for x is equal to 0, the image is 1. We'll have this point right here. Okay, so if we want to find the limits when x tends to 0 of f of x, that will be absolutely not f of 0, which is 3. 1. So the limit when x tends to 0 is not equal to 1, because we are not interested to know what's happening when x is equal to 0. That is not what we are looking for. We want to know what's happening when x is very close to 0 from the right side and from the left side. That's what we want to know. So if we get very close to 0 from the right side, if you get very, 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 very close to 0 from the right side, the limit will be 0. We are getting very close to 0. Okay, so the limit when x tends to 0 from the right side is 0. And if we get very close to 0 from the left side, if you get very, very close to 0 from the left side, so we are getting very close to 0. And then the limit when x tends to 0 from the left side is 0. So the both right-sided limit and left-side limit are equal and are equal to 0. So we say that the limit when x tends to 0 of f of x is equal to 0 and not 1. So from here we can notice that the limit and the image don't necessarily have the same value and they don't have the same meaning at all. So I hope now that you better understand what's the difference between the limit when x tends to a and f of a. And usually we're interested to find the limit of a function on the points where the function is not defined, or at the boundaries of the domain of definition of a function. So for this function, for example, we might be interested to know the limit at minus infinity, plus infinity, and 0. So that was all for this video. I hope it was really useful, and see you in the next video.